Okay, so I'd like to make sure that all the speakers today are available for this discussion. So that's starting with Daniel and Paul and James, George, and myself. And then other people, I mean, everybody will certainly be taking part in this, but I just want to make sure that those people are available.
Yeah, so we're going to be recording this as well, and I guess this is the view that we'll see in the recording.
Good.
Yeah.
All right. Let's see. Are we ready? Let me take a view of the gallery. Yes. Okay. So thank you. This has been, at least for me, interesting to hear all the different presentations today. And there's a lot that strains our credibility, our credulity, but at the same time, it really needs to be strained, because there's a lot of strong evidence out there. Let's have a little bit of a discussion about that. Before we do, I'd like to talk about the host for this part of the workshop, that is the symposium, and that is the Society for Scientific Exploration. The Society for Scientific Exploration is a group of scientists who look at anomalies. They look at scientific anomalies that are not necessarily accepted by the mainstream and examine them fairly rigorously using a thorough scientific approach. And it's an organization that I've found to be absolutely fascinating. The conferences for the SSE are more interesting by far than those of any other organization I've been to. And so for those of you who may be interested, I suggest you take a look at the SSE, the Society for Scientific Exploration. You can find us online, and you can join either as a full member, as a scientist, or lay people as well can join as associate members and help the organization also read the various publications of the organization. And there are more symposia like this one on other subjects. Also, the Journal for Scientific Exploration is a rigorously peer-reviewed journal put out by the Society. And we are going to, starting immediately after this conference, issue 2 calls for papers. One is a call for papers on advanced propulsion, as discussed in the first part of this conference, and a call for papers on advanced energy concepts, as discussed today. And so all the speakers in particular are invited to submit articles to the Journal for Scientific Exploration, and you'll be hearing more about that in the future by email. Okay, so let's have our little panel discussion here, in which we go over perhaps some of the questions that were raised today, and also extend the questions to cover related topics. And for this panel discussion, I've got a little nasty timer, which I'll use so that all responses from the panel or anybody else, please be limited to as short as you can, under a minute if possible, but the beep will go off after 2 minutes, just so that we can have as many different views as possible. So the first question that I'd like to ask of the panelists, and then have the general audience as well give opinions on, is what would it take you to convince, what would it take to convince you that there was a genuine second law violation? what makes you skeptical and what would overcome that skepticism? Who would like to start on the panel?
Well, I'll start, I guess. From the lab scale where I generally work, I want to reiterate that applying the proper measurement techniques and the proper instrumentation, which is accepted by all the people who have worked in these areas from the micro scale up to the lab scale, need to be rigorously adhered to, and that the application of the correct measurement systems, including instrumentation, including the way the experiment is undertaken, and especially the provision of control experiments is required to convince me that there's something there. What we haven't seen too much in the or emphasized as much as I would like in this discussion is the installation or the change of the parameters, you might say, to include control experiments that would normally be considered to not or to give the same effect, but come from a prosaic source. So I try to always emphasize the provision of control experiments. Of course, I'm looking at it from the macro or the lab scale, where it's relatively easy to produce and consider control experiments. From at the micro scale, that's a different kettle of fish. I'll stop there.
Thank you. Daniel.
Yeah, adding on to that, I think it would be very useful to have not just experiments, but a theoretical understanding of what's going on. A black box is good up to a point if you've done sufficient number of controls. If you end up buying this device powering a phone or a TV or something from Walmart, you can probably trust it as being a second law violator, because if it's making money and they spend a lot of time perfecting the device, it probably works. But if it's coming straight out of the lab, what I've been disappointed in general is insufficient theoretical explanations for what's going on, and it's easy to kind of hide behind things if you don't have that. So the three basic pillars of science are physics right now, where you have theory, experiment, and numerical simulation. If all of those come together, that'd be a pretty convincing package, I think.
Comment on that. Philip Anderson came out with an article 30 years ago in Physics Today, in which he said that one of the problems in scientific research today is that we don't believe a phenomena if we don't have a theory for it. He said that's a mistake. We need the measurements to lead and the theory to follow.
Well, yeah, I agree with that. I mean, the proof's in the pudding. I mean, the second law is an experimental fact of nature, and therefore only a experimental violation of it is sufficient to actually bring it down. But at the same time, in terms of convincing people, what I have found in my life is that until you have a convincing theory plus the experiment, people aren't going to even look at it carefully.
Thank you. James, I think you were going to say something.
Yes. So according to my result, we now really think pretty convincing there are two types of energy processes. So the type B is have a symmetric structure, then nearly isothermally utilize heat energy. So now the reason is that I think from the implication of this identification type B is you don't want to say challenge the second law. It's like, look at the second law. Second law is based on idealized gas law, right? You have, I think, remember the Carnot cycle, actually this is one of the way of saying it, okay, most accepted. You have this Carnot cycle is PV, this whole thing, right? It's based on idealized gas law. So you are assuming ideal gas law, of course, the particle and more three dimension because volume, right? Your 3Ds, okay? And there's no consideration of symmetric. You see that, right? It's considered all freedom, right? And then if you base on ideal gas law, you cannot close the eye, I'm going to apply everywhere. Now in biochemistry, we actually have like the kinetic, enzymatic kinetic theory called, it's called, it's well developed for enzymatic kinetic theory. It's based on certain assumption. You couldn't apply that theory only to the cases where you fit the thing here. For example, the kinetic kinetic theory currently well accepted, we teach every year, cannot apply into a hemoglobin. That's another enzyme, right? It says so because the enzyme have, it's not fit that definition initially, okay? Now you based on the idea of gas law, now you try to close the eye to apply everything, including when you have a symmetric structure. Now for our proton, you don't have a 3-dimensional anymore. Initial proton in the 3-dimensional, right? If you localize, of course they are like in liquid water. Yes, they do. But when they are localized on the surface, it becomes 2-dimensional. So your volumes, you see, it's PV, it's not exist anymore.
Yeah.
And then you're still doing that thing, and then basically you get a problem. So I will say, now we clearly understand these are natural occurring everywhere. We want to say, hey, second law applies into part A. But type B, you don't want to say violation. We say if you want to challenge it, we say challenge applicability or the universality of second law. You don't challenge second law,
Okay.
because second law is well done. It's we see ATP hydrolysis follows absolutely well, right? In biochemistry, we see some of the tools that follows excellent. Yeah, I will say make sure we understand. Second law apply to type A. But you have a symmetry, be careful, okay? Yeah, you can apply it, close your eye, many professors does, then you'll miss very important things. I will tell them. Then people, hey,
Thank you. I need to cut you off. We just want to get on to the next people.
Sure, yes.
Yeah, it's, let me also ask this question to Paul. So what would it take to convince you that there was a violation? And what would it take to convince you that there was a violation in your own lab?
When Daniel and you and I chatted, I'm not a big second law expert, honestly. So I looked at, in my mind, I kind of gave up on a lot of these second law things, at least in my area, because I look at just the Brownian motion phenomenon, which is kind of at the heart of everything I'm doing now. Here's this particle sitting in a constant temperature environment. It's transferring its energy to the environment and coming to a stop. And then the environment is transferring energy back to it, giving it kinetic energy. And it's a cyclic process of losing energy, gaining energy, losing energy. I mean, you couldn't develop this model if you said, oh, I'm going to follow the second law and make sure that at each step of time, this is followed. So to me, I don't know, I kind of see it as a long time ensemble average, requirement, not really something that is really guiding me or helping me, find answers to the problems I'm looking at. I don't know. Daniel, he has a strong opinion on a deeper insight, I should say, into these things. People ask me, I say these things, that violates the Calvin-Planck statement, but well, yeah, I mean, you had to violate it to develop the kinetic theory of statistical mechanics. So I'm a little puzzled by the whole conversation in that sense, at that level.
Daniel, do you want to respond?
I don't know what kind of response would be appropriate here. I mean, I do have strong opinions. I may have, after all, I might not, Garrett. But I go back to the Kelvin-Planck form, Paul, and just ask the question: can you set up a situation where you're getting work out of your system, and in a cyclic process, turning heat into work? And if it keeps going that way, and your system cools and you're getting work out continuously, and it keeps operating, that's pretty much a second law violator, whether you want to say so or not. And I don't know. Are you? is that possible with your device? That's a simple question. Can you do that?
Well, I think when we analyze our statistical variables, we definitely satisfy the first and second law in terms of the heat and the work and the energy. But on short time scales, doesn't seem to be necessary.
Right. But Garrett, I'm sorry to, I'm being asked to answer. I'm kind of exceeding my time. So I'll tell you what, I'll back away and save my time for something else.
This is a discussion that I believe is going to continue for quite a while.
Yes.
This particular issue. So let's.
Yes. I think so.
Somebody else want to.
Germano. Germano hasn't weighed in.
Oh yeah, I'm sorry. That's right. It's late at night.
Okay, Garrett. Yeah. Well, I share pretty much the position of Daniel. If we stick to, well, my answer will be probably a trivial one. And if we stick to the classical definition or statement of the second law, the Planck and the Clausius one, well, although I am more of a theoretical physicist, the only way to convince me of a genuine violation of the second law is seeing before me a device that, when switched off, generates a microscopic current and cools down the ambient temperature around it. And obviously, it must work like this. With no time limit. In fact, every one of us, I believe, will be able to build a machine like this one that work like this, but for a limited period of time. Take, for instance, a box with inside a battery and what is called an instant ice pack. Okay, this device will produce energy and cools down the ambient heat, but only for a very limited period of time. If we are able to build a machine, a small machine that does this work cyclically, for me, this is a very, very good example of a machine that convinced me of the violation of the second law.
Thank you. So we need to show cooling. Would other people like to address this issue of what would convince you that the second law is violated? And again, please keep your answers short.
Yeah, I just wanted to say that what Jean-Louis Fan said to us on Wednesday, and he's one of the foremost experts on thermodynamics, and he told us that, hey, detailed balance, that can be broken all the time, right? It's an ensemble effect, and don't worry about the detailed balance. So I think that goes to your work, Paul, and what I kind of heard you saying there. So, but as far as like demonstrating that you violated the second law, I go with George, hey, let's have definitive experimental proof. And that's really hard to get to.
Okay.
Sorry. I think it really has to come from the experimental side, because entropy is so baked into just every theoretical model we have. I mean, I think it was Oppenheimer who said, if your law disagrees with the experiment, your law is wrong. But if your experiment disagrees with entropy, your experiment's wrong. And it's so baked into at least how we understand these laws. So either it requires like fundamentally new laws, or there's just like a basic misunderstanding of our theoretical devices that's going on. So I don't see how it would come initially out of the theory. I think that's the big mystery,
Justin, I think you were going to lead your hand up.
Sure. So I'm just going to build upon what I talked about before, that every model is a tool. So when you ask a question, well, you're violating this model, and we've already seen through different presentations that this model has changed, that second law has had many different flavors to it. And certainly the common flavor is that they're talking about a closed system. And in and of itself, it says, well, energy is moving from one thing to another. So that sort of gives you an open system. So there's questions with how the principle, second principle of thermodynamics is actually couched. But then, more importantly, it's that every model is a tool. And that, so you're trying to get those different models to have certain properties. And, conservation of energy is an important property, continuous space, physical properties is another important property. So the whole thing is not to, the goal is not to say, well, it's violating the second law. It's more of, can you create a model that has it? We know at the atomic level, we know at the subparticle level, we know that these things fall apart. There are, over unity energy systems out on the road. I mean, like HHO, or as Maury King says, that it's really structured water devices that are actually powering trucks, and they're actually saving money on energy. So we know that there's lots of places where our physical models break down. And in all the presentations where I saw where people were actually pulling energy out are the same structures that I see when, we're working with, subparticle models or 0 point or ether models, whatever you want to call it. When you look at them, all the properties that James talked about, you talked about, those are the same properties you see time and time again, in research over the last 180 years or so that really seem to be pulling something from 0 point or ether or what have you. So it's I've said my fill. I think that's somebody else's time.
Okay. Oops. Thank you. Okay, let me go on and just to keep things moving, ask a different and related question, and that is, why are there so many misguided researchers working on energy ideas and technologies? Hathaway Lab has gone through zillions of things and really found no strong evidence. Earth Tech International did. Similarly, Coalescence spent a long time looking in depth at cold fusion and LENR and found nothing. Why so many people in this field? So let me first ask the panel to answer if anybody on the panel wants to.
I can.
Is this stuff being recorded?
Yes.
Stuff. I can give a brief answer to that. It's called short memory and laziness. Typically, the kind of researchers that I have come across or have come across me have tremendously short memories and the inability to consider that their ideas have actually been looked at and discarded in 1880 or 1859 or something like that. So there's a memory problem, and I can go into all sorts of others, but that's the first thing that I want to mention about that.
Thank you. Anybody else on the panel?
All right. Yes. To adding on that, I like a Paul's work. Paul's work really demonstrates type B artificial human-made type B energy processes using Brownian motion and charging up. Now his process very clear. He have the diode, a pair of diode is a symmetrical system, a symmetrical component. So the whole system is symmetric, perfectly fitted the type B type of energy process. So I was thinking that when you communicate, you don't, part of the afraid of say, what is second law? You want to say second law does not apply because you have a symmetric, you can cite my paper we already published. When you have a symmetric, cite my actual paper, actually Daniel helping me a lot. We published that paper. You can cite my paper saying, now we have understand there are two types of process on Earth, naturally occurring. What you made is really a solid, authentic type of B process, human-made. And also Daniel's epitope catalysis is also a valid type B energy, but human-made. It's not naturally occurring, of course. So yeah, we need to communicate that because you say challenge second law, people say, this kind of turn off, those kind of pseudo sign, they immediately get that reaction. Now you understand there are two types of energy processes. The reason is you have a symmetric. Remember, the second law came from, from the Carnot cycle, right? I try to explain that in my paper to why, you should not apply here. Yeah. So Daniel actually gave a very good list. So a symmetric is a necessary condition. There are other conditions also Daniel also lists in his talk today, right? So those like, you have to have boundaries, all that. That's also valid. But I think a symmetric sense should be like the key criteria, to see whether they're possible. So that's my point. Okay, don't be afraid saying the technology does not apply. Don't be afraid, because there are people who don't understand. So if we are not trying to change the second law, challenge second law, just like ideal gas law, very good law, beautiful law, and apply many places. And we need that.
Thank you.
Thank you.
Daniel, you had your hand up?
Sure. So the question is, why have there been so many failures? Because it's a hard problem, but also because too few people are working on it. And that has a lot to do with the lack of funding, shame, and cudgeling by the scientific community not to look at these because of fear of failure. I think people who are trying it now are trying things that in many cases could have been tried a long time ago. I often say that the epicatalysis experiment could have been conducted back in the 1870s, probably. It's a 19th century experiment that had to wait to the 21st century to be done, simply because people were not looking, did not look because they didn't think they'd ever find anything. So I think and the same would be true of Germano's ideas. These are ideas that could have been explored a century ago. So it's a strange thing that we haven't looked at it, but I think it has to do with the community of science venerating the second law so much that it's unpopular and unfunded to try to do so.
Well, turning it around, why are there so many erroneous results? People who are believing that they actually are harvesting energy when they're not.
Because they're not doing the experiments well, or they haven't thought things through correctly. There are a lot of reasons. I mean, I think failure is part of science. And if you're not well educated and motivated and so on, then yeah, you can fail a lot more often. But I find it surprising that when a second law challenge comes about, almost nobody repeats it. In fact, ones in the literature have not been repeated. Paul's hasn't, mine haven't. I'd be surprised, Garrett, if anyone does yours for a long time either. People avoid doing these repetition experiments. I would relish someone trying to repeat some of these experiments, but they aren't being done because the scientific community dissuades people from doing so.
Thank you. Anybody else on the panel?
I can add to that.
Okay.
I've gotten, not to brag or anything, but I've gotten a lot of funding over the years from my semiconductor work and my surface science work, in the millions of dollars. And then when I started switching to, I know I like this problem, and I switched to, basically the Brownian motion of graphene and some kind of energy harvesting aspect of that. I've submitted a bunch of proposals, DOD, I've talked to DARPA, I know David, and NSF, of course. And, there's reviewers that will review your thing and say, oh, hey, this violates the second law, we shouldn't fund it.
Yes.
So that happens. I'll echo that.
I'd like to second that.
I'd like to third that and
I got to support that.
But I think Garrett's question really was, why are there so many garage people, for a better name, out there trying all these things like George pointed out, magnetic motors and this and that. And, people seem to be really driven to find something like that. And that's a really interesting question, I think. And it seems to me that there's something out there, information, and beg my kind of metaphysical discussion here, something floating in the universe that seems to be like, wow, there's something, and we're all striving to find that. And, it's going to land on one of us, but like Picasso said, well, inspiration needs to find you working, right? So when that inspiration comes, it's the people like all you doing the real good hard work that is going to solve it. So that's my 2 cents.
I can add to that too. So I when I published my paper in 2016, I noticed that the statistical properties of graphene had a heavy tail, like a levy flight, a Lorentzian distribution, which is highly unusual, and got very little attention. When we basically said, oh, hey, you know, that actually, since there's a high probability of high velocity movement, that may lead to an energy harvesting concept. It resulted in this huge, you know, press release, you know, and a big pickup in the community. You know, this big altmetric score where I was getting on the order of 1,000 emails. So there's something in the public that's interested in those types of topics versus these other types of topics.
Also,
Ron White had a comment. His hand
Thank you, sir.
has been up for a while.
Yeah, can you guys hear me?
Yeah.
Yes.
You know, I just want to comment on something launching off of a statement that I heard Charles say a long time ago. This is, in some cases, this is all about bookkeeping, and are we bookkeeping all the right things, right? When we're talking about the second law of thermodynamics. So that's kind of like my launching point for just a few small statements I'll make in 60 seconds or less. You heard me talk in my presentation. If you think about physics as a Venn diagram, right? There's two circles on the Venn diagram, and they touch at a tangent point. One of the circles represents general relativity. The other one represents quantum mechanics. So we know there's a more generalized understanding that we have yet to develop. I mean, think about just from general relativity, dark energy and dark matter, 90-some-odd% of the universe. We technically don't even know what it's made of, right? There's a lot of models that are trying to explain it, whether it's mathematical or a real thing. And then just as a final point, you know, for hundreds of years, everyone in science worked to create purely analytic models because we didn't have computers to go through and model anything. And so a lot of simplifying assumptions have been made that baked into a lot of things on how we look at the universe and how we model it and how we study it. And so, but computers have kind of changed that. And so even in the last 50 years, I think we're seeing, you know, new tools and opportunities to go explore things that we couldn't have explored just, you know, a few decades ago. In our work with studying the quantum vacuum with these little Casimir cavities that we're building, and we have to use thousands of CPUs to study those. So all that to say, and this closing statement may not be popular with some here, do we really need to fret too much about the worry of toppling the second law of thermodynamics, right? Because there's still a lot of things that we don't know, and a lot of things we have to make sure we understand. And salute Charles Chase's tenet. We'll at least call it that, the Charles Chase tenet. Are we doing all the proper bookkeeping?
So if I'd like to just respond to that. No, we certainly don't need to topple the second law. And for my technology, I hope that we're not. But the problem is, as Daniel and in a different way, Paul Thibodeau says, the world won't recognize us unless if we appear to be violating the second law. And so the second law is tackling us. It's not that we're necessarily needing to tackle it.
That's not entirely true, Garrett, when looked at from the investor standpoint. And I've been, as I have mentioned in my discussions, been a sort of go-between between moneyed parties and new inventions. And investors in the commercial world use different metrics to determine whether something is efficacious or not worth pursuing. And so you have to sort of shift from a clinical view of whether something's actually possible from looking at a textbook and saying, gosh, the second law says this is not going to work, so I'm not going to invest in it, to, gee, I'm getting some results. Someone is making a bit of progress here. Is it worth continuing that progress, either using a DARPA grant or from a private foundation or an individual or somebody like that? So you have to use a bit different language also. An investor really doesn't care whether you're violating first or second law or any other law for that matter.
So
does the thing produce something?
So that goes along with what Daniel was saying a little earlier, that if you have a product that's profitable, it doesn't matter.
I'm sorry, Garrett, could I just put a small sentence on what you said? And Paul, I agree with you. I don't think neither you nor Paul need to go through and show that you're violating the second law of thermodynamics. I think it just goes back to as Charles talked about, it's bookkeeping and making sure you understand how can you set up some asymmetries, right? Because at the end of the day, my coffee cup always tends to get cold, right? So
just to as a counterpoint to what George said, for our technology, we've brought it to several different larger groups looking for collaboration. And what they usually do is bring in an academic to evaluate whether this could possibly be true. And the academic, those academics tend to be very, very conservative. So let me actually modulate the question a little bit. Why are we so damn conservative, and is it appropriate?
Let me add on that. Conservative, I think, is necessary for science. I actually appreciate George and Martin, in Germany doing that kind of verification. That's important to maintain the scientific integrity and test out those false ideas. Now, so the whole thing, why the second law part of that is not accepted, everybody says, why the Chinese second law, why the second law, they can reject you. Department of Energy, actually, they have a statement that anything why the second law, they will not fund. So this matters, right? Okay. So this is going to take a long time. So there's a part of history, because in the past, when the second law come out, nobody understands. They're thinking the old idea, this whole second law is not false, and they can make perpetual machines. So many of those is not true. Okay, it's indeed a false ideas law. And that's get very bad names. So then, so that as soon as they say, perpetual machine or why the second law, they will say, you're faking science, or you're no good. That's the problem. So it's going to take a long time to convince. So now, hopefully, we now understand there are natural processes. They are type B, we now clearly identify, on the equation, very clear, there's no ambiguity there. Even on equation, said explicitly, RT is there. And so, and now you can say the reason why, because second law from ideal gas law. You don't have a symmetry going on here, okay? You do, so you be careful, So that's why we say here, second law is a wonderful law. I would say it's like all the testimony. Type B, that process will be a new testimony be derived about. So first, the old testimony is valuable. Don't reject second law, don't topple second law. Okay, just like ideal gas, so they're valid. So you say, why the second? Of course, everybody get very upset, right? Especially they don't understand. First of all, they go, no, they're not gonna fund you. Okay, I think we need to communicate better. I strongly recommend. We don't want to say topple, anti, or challenge second law. We'll say there are two types of processes you apply in these places, not everywhere, sir. That's the message. Second law is valid. Don't topple it. Thank you.
Thank you.
I'd like to bring in, if I could, 5 new topics, and they might shed some light, if that's at all possible. I think historically we have to look at Babbage. Don't forget when Babbage created a computer and how many decades went by before it was even looked at again. Just think about it. You could have had a computer had the French government not pulled back the money the military was giving Babbage to develop it. That's one concept. The second concept is the concept of how simple things are once you know how they work. Look at all the people who try to fly. Look at all the attempts of doing a flying machine. The Wright brothers looked at the birds, learned a lot, and now the average kid can make a little glider that flies that they could have never done years ago. And you can understand how it works. Look at simple things that are actually incredibly simple. A vacuum tube, an X-ray tube. Back in the days when I first in the 60s did lasers, they were just very simple things. Transistors even, although that gets into the micro stuff. So many things are simple. A gyroscope, the electric motor, they tried to do motors for years. And finally, one guy got the commutators right. Even the internal combustion engine, it had a couple of tricks. The camshaft, the multiple valve cylinders, on and on and on, but it has about 5, 6, 7 tricks, even a bicycle, precession, and the way the cantilevered wheels and so on. So these are all things, once we get it, it's simple and we understand it, but it was this trick. And then the last thing I wanted to bring up, I have 10 more, but I won't hog, is the concept that people must die. In order to have progress, people must die. And the reason why they must die is I remember in the early days, I did the first instrumentation on an airplane, and it was to just simply do the fuel tank. And it was done by wire, and it was to measure the fuel in a fuel tank. And this old guy at Boeing opposed it and opposed it and opposed it. We were doing it for Simmons Precision. And all of a sudden I get the call one day, he died. So now we can move forward. And so when you're talking about these organizations and these peer review boards, they consist of people. And these people are dead in their ways, and they're super opposed things, and they make things not happen, and they're powerful people. They've got to die. In fact, who said this was Planck? He said, you're not going to get new physics until enough people die.
Yes, so I think, Garrett, does that answer your question as to why you guys are all so conservative?
Yeah.
Right. I mean, that seems like a good social factor in the whole conservative nature of academia, which you guys got to be right, though. I mean, if you're wrong about something, man, you get run over the coals.
Even so.
Yeah.
Even so, can we freshen the way that we speak? I mean, sometimes even just rearranging the way that we discuss items and frame our questions can make a huge difference in solving. And I find this to be true. You know, I hear the same things repeated again and again and again. I've listened to all of the sessions these 5 days, and people speak about light in the same way. They quote this law, this rule, that law. And I hear you all phrasing things the same way every time you say it. And I just challenge you to think about the ways that you're speaking about fundamental energy and light, and perhaps reframe some of your questions. I encourage you to watch all of the talks over these past 5 days, catch up with some truly fantastic, really good ideas. And Charles recorded an intro yesterday that's at the top of our blog page, and I would read that. I would listen to that too. That was a good one.
Okay.
Well done.
Thank you.
I want to get that in.
Are there people who haven't spoken yet this afternoon who have some comments? I think some people may be quiet but have something to say.
Okay, I'll say something.
It looks like Jack Sarfati has a comment.
So,
I'm Bob Bruick. I will have something to say.
I think Jack Sarfati, are you trying to say something? You're on mute.
You're on mute.
You're on mute. Can't hear you. No?
Okay, shall I speak?
Yes.
Okay.
No, I'm actually,
no.
Sorry, I'm trying to get Jack Sarfati to speak, but hello?
Oh.
Jack, the mute button's on the bottom left of the bezel.
No, it's not working.
Garrett.
Yes, is there somebody else who hasn't spoken today? I just want to.
I'm Bob Bruick. I'm not a part of your panel. I have not spoke.
Please.
Can I share just a couple of observations or questions?
Go ahead, Bob.
I have followed this work since 2006 when I went to a symposium that Dr. Sheehan had out in San Diego. My motivation has been different. It's been to see where physics needs to be extended to take into the support paranormal and non-locality kind of situation. So if measurements of energy violating the second law all use language and terminology of a closed system. If system is not closed, and for instance, there is a 0-point field existing, then there's no surprise that there is violation of this second law. The issue to me is one of is time really, as we have assumed it with this simultaneous energy and photon exchange in causality, or is time really a duration? And at the Planck limits of 10 to the minus 44, we aren't even close to examining what the limit is in our own model, which right now the best measurements I've been informed of are about 10 to the minus 23. And everything that's been discussed today has been pretty slow stuff.
Okay, so
And did you have a response?
Jack's up. Jack's ready to go.
Okay.
Yeah.
Please, Jack.
so a couple of things. Has anybody considered? Can you hear me?
Yep.
Yeah.
What happens when you make a Carnot engine with a negative spin temperature coupled to a classical positive temperature? What's the efficiency?
You tell us.
Check that one out. Turns out you have 100%. It turns out that heat is sucked, according to the second law, according to classical second law, the Carnot equation. Heat is sucked out of both reservoirs and converted entirely into work. It's not a violation of second law. It is the second law. With negative, quantum spin temperatures, and is a quantum effect. So, have any of you thought about that?
How do you build one?
Yeah, how do you set up a system that has the negative spin temperature that is separate from a positive
Well,
spin
that's good.
system?
Well, I don't. Yeah, that's a good question.
Well, the second law is an
But it
experimental
depends.
statement.
I'm just going over the what the mathematics says. I mean, I'm not, figure out an experiment. That's why it should be impossible. Well, is there some law of nature saying you cannot, the spin degree, you can't couple the spin degrees of freedom to the lattice degrees of freedom? So I think it's called spin orbit coupling. I think you should be able to do that.
Yeah, but spin orbit coupling and spin temperature, I liken to electron temperature, which is a different class of thermodynamic thing.
I don't see why. No, I don't see why. I don't say. I mean, I have faith in mathematics. I'm a theoretical physicist. I see the equation says. I mean, it's an experimental issue. I mean, I don't see why it should be a fundamental law that you cannot run a Carnot engine between a negative and a positive temperature.
So I think the answer.
Yes, you can, but it's not obvious you can.
So I think the answer here is that really theorists ought to be building things rather than experimentalists.
Well, I don't know, but I did. Okay, there is a book. There's a Zemansky. Dover. There's an old book by Zemansky. Sears and Zemansky, and he talks about Carnot engine between two negative temperatures, but he doesn't talk about positive and negative. So it's in Zemansky's standard textbook from years ago. That there's a Carnot engine between two negative temperatures. So I don't see any fundamental, just reason not to. Okay, the other thing is about the other change topic about the real and virtual particles. And was it Garrett was asking, is it with the cotangent formula, are they unified? And yes, the Hawking evaporation of black holes and Unruh. The distinction between virtual particles and real particles is not invariant under non-inertial frame transformation to general relativity. In other words, if you have a particle detector that has a proper acceleration, it's really accelerating relative to the gravitational metric field. It sees black body radiation that depends upon its proper acceleration, off its geodesic path. So that means that the inertial observer will see just 0 point photons, but the guy next to him who's accelerating will see some of these virtual photons become real photons. I guess because there's an external force on the detector is doing work, so it's providing the energy to upgrade the virtual photons into real photons. So the distinction, I mean, the distinction between real and virtual particles is not an absolute distinction. It's contingent on acceleration of the detector. So I think that's relevant to what Garrett was asking.
Yes, thank you. Gene Kidman had, you had your hand up.
Yes, so I'm a chemical engineer, and I've been interested in energy for some time. I did an analysis on a reaction that really brings an interesting thought about entropy. In this reaction I analyzed, it was a reaction by Santilli done on what he calls intermediate fusion. And I was able to find with a high degree of accuracy, there was a tremendous amount of transmutation. And I was able actually, from the mass balance, able to show a chemical reaction equation. It was that precise. But the weird thing about it was that about 4/10,000ths of the energy that would be predicted by that mass loss shows up as heat, and the rest, well, who knows what happens to it? Which brings up the crazy question, simply that the possibility that there is something that composes entropy that has nothing to do with this concept of order and disorder, but is actually perhaps some kind of mass or energy that comes off the reaction.
Daniel, did you have a thought about this? Okay. So
there would be a very nice correlate gene to that, because entropy can be either the physics view of entropy, or it can be the Shannon informational view of entropy, and the twain should never meet. I have a story I could tell you as Shannon was dying when he told me why he never connected the two, but we don't have the time for that. But at any rate, what you're alluding to is that the entropy takes on a form right now of information disorder, and it might have a correlate into a physical form.
Yeah, yes, that's true. In fact, there have been measurements made by the Russians of something they call strange radiation, where they capture this radiation that they can block as far as light is concerned, and it gets trapped because of its momentum in water, and then can be forced back out of the water by a laser, and it creates some kind of interaction with an emulsion or a film. And so they've got these strange radiation tracks, that's what they call it. And beyond that, who knows what the devil it is. But yeah, I think there's some interesting data out there suggesting the possibility that there is some other form of mass or energy than what we understand through the standard models or through standard radiation. Even a lot of the Eleanor stuff, they get into talking about, there's a guy called Rue who went through and analyzed the radiation off of it and was not able to classify it into any one of the normal classes for the radiation off of those Eleanor reactions.
So thank you. I think you're pointing to more questions than answers, which I think is what our whole discussion today did. And I've got a strong feeling this is not going to be the last time we convene to discuss these issues. So
how about one last question, Garrett?
So,
how about when does Gen 4 arrive? Make a generation 4.
Of what?
Second law devices.
I see. Okay. Next time we meet, we'll have them.
Okay.
You and I will be in production with our devices. So anyway, I'd like to, it's time. I don't want to, I know there's a lot more to say, but I think we'd better call it at this point.
All right.
And, thank you very much for your participation and interest. There's, as I said, much more to pursue, which I'm sure we will do in future conversations. Charles, do you have any final comments?
Yeah, thank you, Garrett. And, really appreciate you joining us this year in the Society for Scientific Exploration. And it's been a wonderful set of talks on this last day of our conference. And, I just want to say we've had 29 talks throughout the 5 days, and near as I can tell, about 150, maybe 175 different participants. So although, it's unfortunate we couldn't meet in person at MIT where you have those really strong heart-to-heart conversations, I think there's other benefits to the Zoom meeting where more people can participate and that as well. And I just, I think our questions are key, right? What are the questions that we're asking? And someone had a quote that, once you ask the right question, the answer is obvious. And I wish I remember who said that. It was someone who had taught him that. And I think we could look at reframing what we're doing by carefully considering the words we use. How do the words we use limit our conceptions? Because words are reductionist, right? The thoughts in our head, we speak some words, they don't really reflect the thoughts in our head. And we use words, kind of willy-nilly, and they're baked in, and it bakes in an idea. So, I think we should really consider the words we're using, and we need to be bold. I go back to Jim Jeski's Dragon King events and situation that could be happening. We really need to be bold. It's not a time to be conservative. And many of us are at, the age of reason, right? Where, we're, at the age where it's time to just really do what our heart says, and, and all the other sort of things be damned. So I would encourage people to, who didn't have a chance to take a look at all the videos or online. And, I just wanted to list, we've talked about the forcing function. We talked about light and EM. We talked about vacuum fluctuations. We covered some new theories from different viewpoints. We talked about testing of some of these unusual devices. And today we talked about second law violations. So I always believe that it's through this multidisciplinary, multi-viewpoint sort of thing that maybe we can come up with new conceptions, new ideas that we can then go off and make something happen. So, finally, I just thank everybody for participating and everyone who gave talks. And, I just really love the open discussions and everyone seeking things out there. Thank you very much. Appreciate it.
Thank you for organizing, and thank everybody for being bold and sharing.
Yeah, thank you.
Great work.
Thank you, Charles and Garrett.
Take care, everyone.
Yeah, thank you.
Goodbye.
Charles, thanks, Garrett.
Goodbye. Thank you.
Thanks, Charles, for everything.
Yeah, it was amazing.
Thank you all. Thanks.
I look forward to seeing you all in person next year. Be well.
Yes.
Yes.
Be daring. Be brave.
Yeah, Charlie, I think to move on from here, I think, education is most important. I think, publish some of the papers. And Daniel, I actually also edited a special issue in energetics. So academic, advanced thermodynamic and type B energy process. Anyone interested in submit paper will be great, welcome. And then we need to educate, because it's the resistance in the scientific community is very strong because they don't understand. We need to better educate. Thank you. Yes. That's my point. Yeah. So anyone here from message, if anyone have discovery on type B energy processes, communicate with me, email me, and we will very happy to very open mind look into your discovery and communicate with the scientific society better. Thank you.
Thank you so much.
Thank you.
Yes. Okay, well, hopefully we can meet in person next year.
Yeah, Charlie and everyone and Professor Model, thank you. That was good.
Yeah.
Good session.
Right.
Very nice session. Yeah.
All right. Take care, everyone.
Thanks.
Thanks. Bye-bye, Charles.
Bye.
Bye, Garrett.
Goodbye.
Bye.
Oh, Charles, can you send the recordings to Annalisa?
Well, they're super huge. Maybe she can pick them up off of YouTube and download them, or maybe there's a Dropbox way. I'm not very good at that.
Okay, I'll ask her to initiate.
Yeah, I'm not really sure the best way to do that.
Excuse me, Charles, I can weigh in on that. Garrett, she can definitely download them from our YouTube channel. If she has a downloading software, you're welcome to do that. It's all open source. And if you'd like the videos intact, they are very large files, but I can do Dropbox or something like that if you just want the files. Just let me know. My email is kate@unlab.us, and I'll put that in the chat.
Okay, thank you.
Charles, Kate, is there any chance of getting PowerPoints and PDFs for we folks who do things in nonlinear order?
Well, that's I'm going to be asking the speakers who would allow their presentations to be put up on our website. So we'll see. I put my charts up there. So that's something.
Really great thing.
Yeah, I can do mine one. No problem. Yeah, let's support that.
I think if you sent out a formal request to do so, they might be much quickly forthcoming, and then you can put them up on your website.
Yeah, I'm definitely going to do that, Robert. Thank you.
Yeah, 29 hours of videos a bit much rather than randomly looking for good stuff in PowerPoints.
All right.
You can't text search a video as yet.
Robert, we have transcripts of the chats too that I can email you.
Well, that would be wonderful. Absolutely wonderful.
Yeah, we
What
consider
I'll
it
do
our
is
data.
I'll get you back a diagram that summarizes all the connectivity. How do you like that?
I like everything about it, and I can't wait to see you again. Thanks for participating.
Terrific, ditto. Thank you so much. Take care. Be well.
The consciousness research.
Yeah, say that again, Jacek.
Pardon, Jacek. If you want to pronounce my Polish first name is Jacek.
Jacek. Oh, thank you so much. Yes, Jacek.
Jacek.
You have to spell it phonetically.
Or Jack. Jack is also right.
Jack is okay. Jacek. Okay.
Yes.
Yes, back to the root of this master who is researching. So you can experience something very, very beautiful. This zero entropy. It's perfect harmony, beauty, love, compassion, everything. It's just this light, perfect harmony, zero entropy. I assure you, it's something different to think it out as to experience is directly from the guts.
Yes.
Yeah, it's possible.
Yes.
And then this multiple unlimited functions of our mind states just open for everything, the essence from everything. And we have to dissolve the mental barrier between spirituality and science. It happened in our history several centuries ago as the science emerged. So one said, no religion, it's not reasonable, it's not common sense, just science, not outer. And we forgot the master. Who is the master? And we can go the both direction. I was struck by Garrett as he said, yeah, I'm I'm personally, I'm not a professional in quantum and theory, but he said in quantum region there is zero entropy, right? Zero, perfect harmony, perfect. So this second law valuation, we are this violation.
I am with you 100%.
Yes.
Uh-huh.
So I was taking, there is a team, I think in Australia, our spiritual teacher in Berlin sent me a mail if I could put a questionnaire about my experience in my meditation. And I just wrote down this process. Several months, it was actually September, several months later, I became the letter from this man who organized this for the scientists. And he was so grateful. So my account was so valid for him, and it pushed these research much forward. And there are many forgotten treasures in our culture, in our experience, that we forgotten, and it is tragic, really.
Yes.
We have to go back to this experience.
Yes.
Join science with spirituality.
Yes.
So we can only then we'll go forward. But I see you all folks say about your experiences, and I see it. It goes in this perfect harmony, in this sea ocean of energy, of beauty, of freedom, of everything.
Yes.
And this is our home. We are longing to get there.
Yes.
There's no death. There's no death. We are when we lose this body, we'll get another one. And
yes.
The point is to get the right one. And this is a karma. You have to avoid evil, do good thing, and help others. This key points of everything, of our success as humanity. That's it.
Yes.
That's it.
And
I love you all.
And we're all part of that.
We are a part of that.
That perfect entropy. No entropy.
Right.
That is us. That is us.
Yes. We are part of this entropy. We are this entropy.
We are this entropy. Yes, sir.
We are this entropy. Right.
Yes.
See you.
Yes. Send me an email or something, please.
Yes. I had a idea. Last day was so exciting for me. I couldn't sleep until 2 at night. Same idea. Let's set up the assumption of true physics. I will write down and send you. How do you feel about?
Yes, please do.
Because I see in my intuition, it goes with this. So the quasi axioms of being. Time is being. No time, no being.
Right. Yes, and then there's the the universe where there is no time. I mean, there is a place where you can be where there is no time, and all of time is there at once.
But this is one aspect. The second aspect of the void is a function of our entropy, and these functions are limitless. That's why there are so limitless this failure. The other hand, the last question, why do we have so many failures? Because there are many functions in our mind. This is only one mind. It tries this way, this way, this way, this way, this way, this way, this way. And is everything okay? Without failure, you wouldn't be wiser.
Yeah, we're here to experience.
Yes. So go forward.
Yes. Thank you. Thank you so much for that. That's beautiful.
Thank you so much. It was
Yes.
really, really inspiring.
Yes.
Right.
Thank you.
Bye-bye.
Bye.
Thank you, Charlie. Charlie, sometimes maybe sometime when you have time, can I have individual meeting with you maybe a few weeks later or sometime when you are convenient?
Yes, certainly. Oh, yes, that would be wonderful.
I want to like a chat with you, maybe on Zoom. We can schedule something, right? Okay.
Yes.
When you feel, yeah. Okay. Thank you.
That'd be wonderful.
It's a
Thank you,
wonderful
sir.
session. Yes, I think it's wonderful. Thank
Charles,
you. Yeah.
Charles, one last bureaucratic tech thing. One thing that's missing from this year that was very much all we say about the first 3 years is you had a list of contact info. And now we don't. So can you pull together everybody's contact info?
Yeah, so we tried to gather everyone's email, and we're going to be putting that together.
You need phone nowadays, because
that will be helpful.
All the follow-ups after this meeting.
Yes, yes.
Yeah, that will be very helpful. Yes,
Okay.
contact information. Sure.
Yes.
Thank you, both of you. Wonderful. I think. Thank you.
Yeah.
Contact information very helpful. Yes.
Yes. Yes.
To move on from here.
Gennady, did you have something you would like to say, or?
Me?
No, Gennady seems to be here, listening. I don't know. I just wanted to give you a chance. Bye.
Bye. Thank you.
Okay, I'm going to hang up now. Take care, everyone.
Such a pleasure.
Bye, Robert. So nice hearing you again.
Yes, we will be meeting for
Yes.
sure.
Yes.
Take care of my good friend Evan.
Yes, we will.
Boy, that's going to be fun, isn't it? You can imagine how excited I am.
At 24, he's going to become a man. That's great.
Right, exactly.
And he'll get to play
He's
tennis
going
every
nuts
day.
over the carriage. He loves the carriage house. I think that was so great. So great.
Oh, nice.
He can be isolated, no roommates. I told him this is the ideal life you want. Skip over roommates, you know?
Yeah. For an introverts like us, it's perfect, right?
Yes,
And,
yes.
he's only a mile and a half from our house, and he's right in between our house and the tennis courts. And so he's a
I know.
karate.
This is ideal. This
He'll
is
miss
ideal.
karate, but he'll play tennis with
Maybe
us.
he can find a new karate spot.
He'll
Yeah.
find a club down there, I'm sure.
Yeah.
He'll find it. It might be 20 miles away, but he'll find a club.
He's got
So
such
he's
a
really
unique
come out.
intelligence.
Yeah.
Yeah. It'd be fun.
My main job the last 6 months, which was very successful, was getting him off video games.
Getting him off what?
Video games.
Video.
Oh.
He loves his video games. Yes, he does.
Well, since
No,
we're going
no,
to be
you got him
building,
off it.
since we're going to be building the model, one of the ideas is to make it enjoyable, like a game. So his love of gaming will probably actually come in handy.
It'll come in handy in the model we're designing. Yes.
All right. Well, let's go make dinner.
Yeah. And Diane, I just wanted to say, I like your thought. Yay, let's be the violation.
Yeah.
Let's go. All right. Thank you very much, everyone. Bye.
Bye.
Good night.
So nice to see you, Robert.